As you just saw there, we have reignited the second stage. And this burn is going to last for about a minute. This is raising the apogee of our orbit so that we can drop TESS off at a place where it can then properly begin to perform its own orbit raising maneuvers to get it to that point where it can perform its lunar flyby. We are beginning to throttle everything down, hearing that everything is looking totally normal on this burn, which is really good news. And the engine has shut down.
Have that cut off.
So for about 5 minutes, the stage is going to coast with TESS on top, at which point the payload is going to deploy. Now, the way that works is there is what is referred to as a payload adapter that is sitting on the top of our second stage, and TESS is attached to that. It's attached via a clamp band, which is basically like a banded spring. We'll send a separation signal to Falcon 9, which will then open up that clamp band, and there will be 4 springs inside of that payload adapter, 4 compression springs that'll give TESS a little gentle push to push it away from stage 2. And after a while, a few minutes after that, TESS is going to turn on its transmitters, on its receivers, deploy its solar arrays, and begin its mission. So let's watch these live views for the next 4 minutes or so, and we'll come back for a live view of payload deploy.
And the second stage burn is complete. The second stage continues, as you can see on your screen there. And with now, we will go to a video of Stephanie Martin, who is going to help you learn a little bit more about how we find exoplanets around habitable zones, the Goldilocks zone of stars. We'll go to that video now.
I'm here with Doug Hudgens, the program scientist for exoplanet exploration. Doug, thank you so much for joining me.
Thank you for inviting me.
Now, can you tell me a little bit about why we study exoplanets?
We study exoplanets because we want to understand first just how planets form and evolve, what the whole exoplanet zoo looks like. Because our own solar system has the 8 planets that we know of, but in fact, finding other solar systems, we find other planets, other types of planets that we maybe don't have in our solar system, but we also find planets that are arranged in different orders, with gas giants close to their star and other planets further away. And all of that tells the story of how planetary systems come to be. The TESS mission basically uses the transit technique to detect exoplanets, which means we watch many stars and look for a tiny dip in brightness that occurs each time a planet orbits and passes in front of the star. Now, when TESS detects a exoplanet transit, really that's just where the science begins, because there are also things out in space that can mimic or might fool us into thinking that there's an exoplanet around the star when in fact it's something else entirely. So the first thing that we have to do is we go to ground-based telescopes. Members of the science community, certainly the TESS science team, will be very involved and very active going to ground-based telescopes, carrying out observations of those transiting systems to kind of rule out the astronomical false positives that might trick us.
Now, how can citizen scientists and amateur astronomers help look for these exoplanets?
Well, this is really exciting. The nice thing, the great thing, the exciting thing about TESS is that it is going to be looking at the nearest and brightest stars to the Earth. Now, its predecessor, the Kepler mission, which did a fantastic job in discovering a huge number of planets, most of the stars that it looked at were very faint. And largely beyond the grasp of amateur-sized telescopes. TESS is looking at stars that are going to be brighter and much more accessible to ground-based observations and to amateur telescopes. So scientists that have a good quality telescope are going to be able to themselves contribute by carrying out observations of these systems just simply because they're more amenable to their equipment.
Now, how did these amateur astronomers get involved?
In just under a minute here, we'll be seeing the spacecraft separate from Falcon 9. Look at that beautiful image of the Earth behind us there. Just one of the planets TESS is going to look at in its lifetime. And as you can see there, we have had successful separation of the TESS spacecraft. And it's going on its beautiful mission to look at thousands of planets outside of our solar system. And with that brings us to an end of our webcast, as Falcon 9's job is done for today. So this was a pretty successful mission, right? We had a successful stage 1 ascent and landing. Stage 2 has properly deployed the TESS spacecraft into its intended orbit, and TESS is now on its way, and hopefully we'll hear soon about the health of the payload. I want to give a big thank you to the NASA Launch Services Program for their faith in us, to Goddard Space Flight Center, to MIT, and to the 45th Space Wing for their range support for today's mission. You can follow SpaceX on social media via our Twitter feed as well as our Instagram. You can also check us out on SpaceX.com. And if you want to learn more about the TESS mission, visit nasa.gov. Thank you all so much for joining today, and we'll catch you at the next launch.
So with the successful deploy of the TESS spacecraft, the next major milestone is the beginning of solar array deployment. That activity is expected about 8.5 minutes after spacecraft separation. So in about 7 minutes from now, we'll of course be back to join the beginning of that. That process will take about 20 minutes to complete. We'll rejoin in time for you to track the deploy of the solar arrays from the TESS spacecraft.
TESS will fly in an orbit that completes 2 loops around the Earth every time the Moon orbits once. This special orbit will allow TESS's camera to monitor each patch of sky constantly, for nearly a month at a time. To get this into orbit, TESS will make a series of loops to build momentum. Then, the Moon's gravity will push TESS to